Okay. Yeah, so the final theme in the document has the title Tools to Tailor Cattle to Different Environments. Thinking about that, I slightly regretted that because it sort of sounds like we want to drastically manipulate cows, which is not really the idea. The idea is more which animal in which environment. So we come back to something that Mons presented in the very first slide about developing solutions that take into account the different environments. And so what I'm going to present here, and I've stolen shamelessly from different PowerPoints from different people, is how we can pull together work that was done on characterizing environments and climate change in Work Package 1, briefly talk again about the G/E methods in Work Package 4, and then the modeling work in Work Package 6. And the context, of course, is that we have a mosaic of farm types across Europe with different topographies, different weather, different marketing systems, and so on, which are all likely to face increasing environmental variability, either directly from climate change or indirectly through notions of less feeding of grain to cattle, more agroecological approaches, which tend to take us towards increasing variability in quality and quantity of feed. And it was clear to us right from the beginning, there's going to be no one-size-fits-all optimal balance between the resilience needs of an environment and the carrying capacity of that environment, which is going to impact the efficiency that's possible in that environment. If I try and frame that issue in terms of a question that a farmer would perhaps ask, then which type of cattle are best for my current and future environment? Slightly different from a breeder perspective, which genotype of cattle would be best, but are also sufficiently resilient in future scenarios. That tends to say that there's probably one type of cattle, and I would suggest that it needn't be just one type of cattle. We've talked about efficient breeding strategies, crossbreeding, mixed farming systems. I mean, those are things that contribute to the mitigation theme that Eileen presented as well. But it was just to try and come up with some questions that frame this particular topic. So in that context, GenTORE has developed some very nice work on quantifying environments. So GenTORE produced in Work Package 1 a data set which combined farm accountancy data and agro-meteorological data into one set, and then published two databases, one for dairy and one for beef. And you can see the kind of results you can draw from those data sets. On the bottom left, we see a sort of an economic capacity of these, economic efficiency of these farms through time. And we can see that in some years, the farm types in the different regions are impacted differently, suggesting differences in resilience of these farm systems, at least economic resilience for different regions. And on the right, these are projections of milk productivity. So the upper panel is showing the current milk productivity by region across Europe. And then predictions for 2030 and 2050 are in the bottom panels. And what we can see is that there are some areas where it's expected that there will be significant changes, significant drops in milk productivity. These are in kilos per hectare, and other areas where there will likely be significant gains. So these are clearly things that are going to need to be taken into account as we future project. On the animal side, these are things that have already been talked about, so I'll go quickly. We have improved phenotyping, we have improved genomic tools, and in particular, different ways of approaching G/E. So Mons presented the work looking at the better accounting of G by E using the heterogeneous SNP variances, covariances. And Eileen briefly presented the work done using systems biology models by Laurence Pouillet, again asking questions about which animals or which combinations of an animal's allocation and acquisition are best in different environments. And bringing that together, work package 6 in the main is developing, and these are works that are still in progress, models to predict performance and farm level resilience for different farm types. There's a social life cycle assessment that's taking into account not just carbon or energy, but taking into account also aspects of the things that you can see in the picture on the bottom right. So things like worker conditions, impact for land use change, and so on. And simulation of consequences of selection for R&E. So that's the little figure that is down at the bottom left, where you can see links between the systems biology model at Cal and breeding scheme simulations, which is a program called ADAM, to try and really look at what will happen if we change the breeding schemes and as we go forwards. I can just see I've got a couple of comments in the chat. They are okay, nothing relevant to what I'm saying just now. And those are things that are being developed. What has been delivered already are on-farm animal ranking tools, which have been mentioned before. These are coming from work package 5. Why is it not going forwards? Here we go. Yep. So, so these are tools which have been deployed in Ireland already, which basically allow a farmer to rank animals in this particular example on their replacement value. So you can see in that little pop-up picture down at the bottom, there's a replacement index. So these are giving farmers the opportunity to rank animals on their perceived profitability and on their perceived stayability. So if I try and spin that into a narrative, I think this is about what have we done for tools that will help us to evaluate the current and future match between genetic environmental resources. So if you're a farmer, you're asking the question, what kind of farm do I have? What are my farm system boundaries? What performance and resilience can I expect from my animals? That allows me to assess, is my current match between my farm environment and my animals good? And to think about options for improving and for longer term consequences. The boxes that have just appeared are my take on the things that we have done within GenTORE to contribute to this. So on the left, the regional farm environment mapping and the G by E prediction tools help us to characterize the system boundaries, help us to understand what kind of animals we have within those environments. And then the modeling work on resilience and efficiency at farm level, the tools to rank of an animal's worth within a farm, help turn that into what are options for improving. And we can go a step further with these broader analyses, the social life cycle analysis, the simulation of long-term selection strategies. So that all looks very wonderful. I did want to bring a little bit of reality to this. So basically over on the left-hand side, these were work packages that started earlier. So we have real concrete results. We have a public database and papers published on the environmental mapping. And this is a tool which I would suggest these databases could be picked up and used with a little bit of adaptation by advisory services. It's the same for the genomic tools. There are a bunch of papers, there's a summer school planned, and these would be fairly rapidly tools that breeders could pick up. As we move across to the right-hand side, and this is perhaps not surprising because this work package started later, we tend to be more things that are in development and things which are really research tools and research methods. And there we would have to probably be a little bit clearer about what would be the steps for those to become application tools, although that won't happen within the lifetime of GenTORE. So that's a quick flyover this particular narrative. And that was my last slide. So it's over to you for comments, questions.